is up at the top, which is the end behavior of a polynomial. So the end behavior is literally just like, what is the graph doing to the far left and what is the graph doing to the far right? There are 4 things that can happen. And so I have this lovely little table here that has all the possible things, and I'm just going to explain each one with the most basic version of a polynomial that would fit into that category. Okay, just with things I hope you guys will remember how to graph. Okay, so the positive and odd. So it's either positive, negative, even, or odd. The positive is literally just to do with the leading coefficient. So I just have an example here that is just y equals x. So the positive would come from the fact that that's positive 1 as your leading coefficient. And the odd or the even comes from the degree of the polynomial. So the degree there, if you just have a plain x, the exponent would be 1. 1 is an odd number. This is the most basic version of a positive odd function. Okay, hopefully you guys, like if I do mx plus b, right? If it's just y equals x, it's right through the origin, and then you would just go up 1 over 1, up 1 over 1 on either side. It should be a perfect diagonal line through the first and third quadrants. Okay, so positive and odd. So the end behavior. What am I doing to the far left? What am I doing to the far right? Okay, on the far left, this part is pointed down, right? This is going to negative infinity. On the far right, the graph is going up. And I should have picked a different highlighter because I feel like this one's not going to go. But the y values there would go to positive infinity. So in terms of the little chart, the end behavior, it's down at the beginning, up at the end. Down means the y values are going down. Up means the y values are going up. So that would be your positive and odd. Okay, now your negative and odd. So I'm just going to do very similar. I just have a negative 1 in front of the x. That's the only thing I changed up. The negative comes from that leading coefficient. The odd, again, the exponent there would still be 1. So if you have negative x, that is a perfect diagonal. Pretend I did a good job drawing that through the second and fourth quadrants. And you'll see the end behavior here is reversed. So on this one, the far left goes to positive infinity, and the far right, the end goes to negative infinity. So this end behavior, this goes up at the beginning of the graph and down at the end of the graph. Now, the last two are both even degrees, and the most basic version that I could get for you would just be a quadratic. We just got done doing that unit. So hopefully you guys could sketch this. Just y equals x squared. Guys, are you writing this down? Okay, fabulous, fabulous, fabulous. All right, if you have an even function. If you have an odd function, I remember this, odd degree, opposite directions. Okay, if you have an even, they both go the same direction. They're either both going to go up or both going to go down. So the most basic version, this is a parabola, right? Both the left side and the right side, both of these go to positive infinity. Positive because this would just have a positive 1 in front of the x squared. It's positive. The squared is the even part. So the exponent is where you get your even or odd. Now, the last one, this is negative even. So negative x squared, you know if you have a negative in front of your x squared, that flips your parabola to go upside down. So the negative 1 in front of that is the negative in that description, and then the even is the exponent. So both ends, the end behavior on both ends here goes down to negative infinity. Oops, sorry, let me go back to the little chart. So positive and even, both ends go up. Negative and even, both ends go down. All right? Is anybody having a question at the moment? Those are the only 4 things that can happen. So we're going to go through, it's all based on the leading term, how you would classify that, and then we can determine our lovely little end behavior. So each of these is in factored form, which ideally we would like this because then we can see where the graph should cross or touch the x-axis. Okay, I have x minus 5, x minus 1, x plus 2. We are not multiplying this out. But if I did multiply this out, could you tell me what the first term would be? X to the third. Okay, now this is how I want to classify my end behavior. So this would be, there's nothing making this negative, so this would be positive, and then my exponent is odd. Okay, odd, the ends go opposite directions. If it's positive, I don't know the best way to remember this. I always just think of the line. But if it's positive and odd, it goes down on the left, up on the right. If it's positive, whatever the arrow is doing on the far right in the end behavior, if it's positive, it'll be going up. So like, if it's positive, the right side should go up no matter what. If it's negative, the right side should go down no matter what. So if you remember odds are opposite, that'll help you. Okay, here's all we're going to do. We're just going to sketch this. All right, so I'm going to identify my zeros. So this should go either through or touch the x-axis. We're going to talk about that here in a second. At 5, at 1, and at -2. Those are my zeros. So this is how I'm going to interact with the x-axis. Now this is, if you look at these graphs I have for you guys, they do have labels on the x-axis. There's no labels on the y-axis because we're just sketching this. We're not plotting specific points. I'm just going to ask for a general shape here. So I do not have any multiplicities here at all, so we don't have to worry about this. We don't have any exponents, so these should just go right through the x-axis. We'll talk about multiplicities on the back. So all I'm going to do, I'm going to go across my x-axis. I'm going to put a dot on the -2. I'm going to put a dot on the 1, and I'm going to put a dot on the 5. Those are the 3 places the graph should go through the x-axis. Now, we're just going to sketch this. It's not going to be perfect. I know, based on my end behavior, on the far left, the graph should go down to -infinity. So I literally just draw the arrow going down. And I also know, based on my end behavior, on the far right, it should go up. So I just draw up. Okay, now, we don't have any multiplicities. We don't have anything weird here. You just go through, like, I'm just sketching, and we're just going to make this kind of a curve. So I'm going to go through the x-axis, but I know I have to come back down to go through the 1. Go ahead, go through the x-axis, and then you know you have to come back up to go through the 5. So it's just a sketch. It doesn't have to be perfect. I don't have labels on the y-axis. It's just something like that. As long as it's curved, you're good. Yes?
Would it be when you're just like for people just like memorize which exponent has what type of graph?
You mean like for the end behavior?
Yeah.
Yeah. I would try to remember those 4 because there's no more than that. There's just 4. Okay, so let's try another one. If you multiplied this out, which I'm not asking you to do, but if you multiplied it out, what would the first term be? -x cubed. Okay, if you're like, what the heck, where are we getting that? If you just take the first thing, like this is -x, x, and x. If I multiply that out, -x times x gives you -x to the third. That's where I'm getting that from. If you want to figure out the first term, the leading term, that gets you your end behavior information once you can figure that out. So this is, because that little negative out in front, this would be negative, and this is odd. So that changes the end behavior. The end behavior here should go up on the left, down on the right. If it's negative, it will always go down on the right side, whether it's even or odd. Odds go opposite directions. Okay, now I'm going to go back and identify my zeros. So I have -x out in front. What would you plug in for that to make that 0? Just 0. The negative doesn't do anything. Okay, it's just 0. If you've an x out in front, you're going to have 0 as one of your answers. All right, this one would be +3. This one would be -3. So I'm just going to go through my x-axis. I'm going to put a dot at -3, put a dot at 0, and I'm going to put a dot at +3. And then I just go back to my little end behavior. Should go up on the left, down on the right, and then we're just going to go, like, I have to go through the -3, but I have to come back up to go through the 0. Then I got to go through the 0, but I got to come back down to go through the 3. And it just kind of draw a wave. That's all. Just everything is going to be a curve here. If you want to look at these on Desmos, you totally can. They'll probably be radically different than my sketch because we're just doing a sketch. We're going to look for, did you pick the correct zeros, and do you have the correct end behavior? Those are the 2 things we're going to look at when we sketch these. Okay, let's try. We got 2 more at the bottom. So if I'm not asking you to do this, but if I multiplied this all out, right, and I just need the first term, because the first term in standard form will tell me everything I need to know for my end behavior. What would it be for this question? X to the what? 4th, x to the 4th. You got 1, 2, 3, 4, x to the 4th. All right, so nothing making this negative. This is positive. That exponent is even. Anytime you have an even degree, both ends go the same direction. If it's positive, they just both go up. And the zeros, that's what I'm going to figure out for my x-axis. So x out in front, that's just 0. X minus 3 would be positive 3. X plus 2 would be negative 2. It's what I would plug in there to make it equal to 0. X minus 5 would be positive 5 as a 0. And then I'm just going to go back to my x-axis and put a dot at negative 2. I'm going to put a dot at 0, put a dot at 3, and put a dot at 5. All right, now, on the far left and the far right, both ends of this are supposed to go up to positive infinity. So just on the whatever zeros on the far left, which is negative 2 for this question, and whatever zeros on the far right, which is 5 for this question, those ends I know just go up. The rest of this, I'm just going to draw a wave. We're going to go, like at the negative 2, I got to go through the x-axis, but I got to come back up to go through the 0. Go through the 0, you got to come back down to go through the 3. Go through the 3, and you got to come back up to go through the 5. It doesn't have to be perfect, but a shape similar to that. Just, do you have the correct zeros? Do you have the correct end behavior? That's what I'm going to look for. All right, and then I have one more. All right, if we multiplied this all out, what would my leading term for this last one be in standard form? Okay, negative 2x to the 4th. You have a 2 right here, so it would be like negative x times 2x times x times x. That would be your highest power. Okay, now, just because it's negative 2, it's not going to be any different way to sketch or anything like that. It's just the fact that it's negative is the information we need there, and then that exponent is even. Anytime you have an even degree polynomial, both ends will go the same direction, just like a parabola. So these both of these ends will go down. Now this one we're going to have to kind of estimate on the graph a little bit. All right, so that negative x out in front, 0 there would be 0. What would be the 0 if you have 2x plus 5? Negative 5 over 2, which, if you prefer, which I kind of do for this, the decimal on that's negative 2.5. I usually use the decimal instead of the fraction to help me kind of estimate where that would be. I got x minus 4, so that's just positive 4, x minus 2, so that's positive 2. So I'm just going to do my best. Negative 2.5, I'm just going to kind of go best I can between negative 2 and negative 3. Let's see, I've got 0, I've got positive 2, and I've got positive 4. So those are the 4 spots that we're going to cross the x-axis. And let's see, I know because this is negative and an even degree that whatever's on the far left should point down. So that's that negative 2.5. Whatever's on the far right, which is the 4, that should point down also. Then I'm just going to literally just kind of make waves through the x-axis. So I got to go through the negative 2.5, but I got to come back down to go through 0. Go through 0, but I got to come back up to go through the 2. And go through the 2, but I got to come back down to go through the 4. So it should look something like that. We're just sketching these. I'm just going to have you make sure you have the correct zeros, the correct end behavior. So that's one of each. Is anybody having a question? Okay. And like I said, if you do want to look at any of these on Desmos, you are welcome to do that. It's going to look a little different. We're just doing a basic sketch. Now, on the back, as you noticed in some of the questions we had yesterday, we had some exponents on some things. And so I want to give you just kind of a couple little examples of if you have a multiplicity, what goes on in terms of the graph. So if you have an even multiplicity, these are my favorite, it creates what we call a bounce. That might not be the technical definition, but basically what happens in an even multiplicity, it's like a parabola. I have a little parabola up here. This would be an example of an even multiplicity, right? Pretend this is just y equals x squared. So 0 would be the 0, right? And you guys can see it doesn't actually go through the x-axis. So it comes down, touches the x-axis, and then bounces back up. So this would be an example of an even multiplicity here. I should have put y equals. If I did x minus 1 squared, right? If you guys think about how we were doing graphing for a parabola, I'd have you do like opposite copy. This is positive 1, 0 would be where the vertex would be at. And if you think about this, basically all this is going to do, this is going to come down, it's going to touch the x-axis, it does not go through, it bounces back up. If you guys thought about the leading coefficient here, we'd have x minus 1 times x minus 1. So x squared would be the leading coefficient, which would be positive and even. But if I only have the 1, 0, both ends have to go up. That's what creates that bounce. It can't go through the x-axis and have other information there because of the end behavior. Both ends have to go up, and both ends do go up. Now, if you have an odd multiplicity, and that we had odd multiplicities on all the questions on the front, they were just linear. There was no exponent, right? This, if I had x minus 2, this would go through negative 2 if I was graphing this. So if you just thought about this, this would actually just be a line, and you could just totally graph the line, but the end behavior, this would be x as your leading coefficient, so that would be positive and odd. So you can see the left side goes down, the right side goes up, it goes through the x-axis. Now, I'm not going to be super picky about this, but technically, if you have an odd multiplicity that is not 1, so if it's like 3, or you're probably not going to see a 5, you might see a 3 though. Sorry, I should have highlighted this. This goes through the x-axis, so it doesn't, like this bounces back, this goes through. Technically, if you have a 3rd power or a 5th power or like a 7th power, the shape looks more like this graph up here. It's not a line, it's like a cubic. If you have x cubed, I'm not going to be picky about this as long as you go through the x-axis. But like if I was graphing this, let me grab a different color. This would be x minus 2 written out 3 times, right? So this would be x to the 3rd as your leading coefficient, which would be positive and odd. So it would go down at the beginning and up at the end. Because this is on negative 2, we'll get into this a little bit more. This would cross the x-axis at 2. It would take a shape kind of like this. Like it would kind of twist at the 0, whereas if it's just an exponent of 1, it would just go straight through like at a diagonal. But if you've got a 3rd power, and like I said, I'm not going to be picky about this, but it should kind of twist to make this shape as you go through, kind of like, it's basically like this would be sort of like thinking about a parabola. This would be like the downside of a parabola, and this would be kind of flipped up. So it kind of twists a little bit. I'm not going to be super picky about it though. So if it has an even multiplicity, you do not go through the x-axis. You bounce back the direction you came from. If you have an odd multiplicity, you're going to go through the x-axis. And I'm going to try and draw these the best I can. So again, these are in factored form, but some of these on the back have exponents. All right, so does anybody know if we multiplied, in example 2 here, if I multiplied this all out, what would your leading coefficient, or your leading term be? The first term. X to the 5th. Okay, and if you're like, what the heck? This would be x minus, or x plus 1 twice, and then x plus 4 3 times. So if we multiplied that all out, I've got 5 x's there. So nothing is making this negative. So this is positive and this is odd, but I'm only going to have 2 places the graph's going to interact with the x-axis. Okay, positive and odd goes down at the beginning and up at the end. Now, here's my best advice. All right, my zeros, I've got, sorry, I shouldn't have written that under there, negative 1. That has a multiplicity of 2. And then we would have negative 4, which has a multiplicity of 3. Now, me personally, if I have an even multiplicity, like when I put that on the graph, I just draw like a little circle around it. So at negative 1, I just draw myself a little circle to tell myself, okay, don't go through the x-axis. So I stop and I go back the direction that I came. Now the -4, that has an odd multiplicity. The multiplicity is 3, so I am going to go through the x-axis there. Now I'm just going to follow what the end behavior is supposed to do. So on the far right, which would be the far left, sorry, the -4, this should go down, and on the far left, this should go up. I'm just gonna kind of come up like this. All right, now I'm not going to be picky about this. This has a multiplicity of 3, so it should kind of curve a little bit here, but you're going to go through the x-axis, and then you know you have to come back down to touch the -1 and bounce back up. That looks really bad, sorry. If you're doing a bounce, like kind of try your best to kind of make it look like a parabola. I didn't do a good job drawing that there, but it's just a sketch. But odd multiplicity, you go through the x-axis, and even you just touch it and then go back the direction you came from. And we didn't have that on any of the questions on the front, but if you have an exponent that is even, don't actually go through. You're just going to touch the x-axis at that point. All right, so like this one. If I write this out, got x squared, x, and x. So this would be x to the 4th. So this is positive and even. So both ends are going to go up. Now, I have 0 with a multiplicity of 2. I have 4, and I have -3. And if I have an even multiplicity like I do here at the 0, I just identify that on the graph, like I'll just circle it to make sure I don't go through the x-axis, that I bounce back the direction I came. So I'm going to put a point, -3, 0, which I'm going to circle to remind myself, don't go through the x-axis, and then 4. And then I'm just going to follow the end behavior. So left side should go up, right side should also go up. Now, at the -3, you're going to go through the x-axis. I'm going to try my best to do this. I'm going to try and like kind of curve into this to draw like a parabola. So it will look kind of like that. Bounce back. You're going to come back down, but you know you have to come back up to go through the 4. So something like that. It doesn't have to be perfect. It doesn't have to match like the height of mine or anything like that. Just as long as you have the correct zeros and the correct end behavior, we're good. Is anybody having a question? Okay, now I'm going to do 2 more at the bottom with you guys. The worst part of these are not in factored form. Okay, so one bonus is you can see the leading term because it's in standard form. So like I know this one is x to the 5th, which is positive and odd, like right away. The problem is I know the end behavior would be down at the beginning, up at the end, but I don't know what the zeros are. So we're going to do what we did yesterday and just go ahead and factor. So on this one, what could I take out in front if I was trying to factor this? What do these all have in common? X to the 3rd. There you go. Yeah, I have at least x to the 3rd in each one of these. Okay, now left over, I'm taking 3 away from each of the exponents. This would be x squared minus 6x plus 9. And tell me 2 numbers that multiply to get you positive 9, add to get you negative 6. Okay, they're both -3. This is actually, that's one of those perfect square trinomials. So I actually have 2 of those, which means that has a multiplicity of 2. So I have an even multiplicity here. All right, so when we do our graph, I have 0. Multiplicity there is 3, so we're going to go through the x-axis, and that x minus 3 appeared twice, so this has a multiplicity of 2, and I just want to remember, if I have an even multiplicity, which that one's 2, do not go through the x-axis at that 0. So I'm going to put a point on my x-axis on 0 and on 3, and I'm just going to circle the 3 so I don't go through the x-axis. Now, my end behavior here is supposed to go down on the far left, so that would just be on 0, and up on the far right. And I'm going to go through the x-axis. This is supposed to be a bounce, so I should just come back down and touch this, and I've already drawn it to bounce back up when I put in the end behavior, so it should look something like that. If you're trying to do a bounce, kind of try to make it kind of look like the shape of like the bounce would be the vertex of a parabola. But again, I'm not going to be super picky. As long as it goes through the correct points on the x-axis and the ends go the correct direction, you're good. And then we're going to try one more here. All right. This last one's got a leading term of negative x to the fourth. So it's all multiplied out. I can see that immediately. This is negative and even. So I know both ends of this graph on the far left and far right are both going to go down when we sketch it. Anybody know what you would factor out if you were going to try to put this in factored form? So I've got negative x to the fourth plus 16x squared. What would you take out? Okay, on the right track. Would anybody else take out anything different? You can't take out x cubed. I would take out negative. Yes. Okay, you want that first term to be positive. I'm going to divide both of those guys by negative x squared. You want, inside the parentheses, you want it to start with a positive, so that would change this to be positive x squared. Now, that will also change that inside term to be negative 16. So then let me ask you, can you tell me two numbers that multiply to get you negative 16, but add up to 0, because I don't have a middle term? Negative 4 and positive 4, yes. You guys are so quiet when you talk. Okay, now, that's completely factored form. Like I said, if it starts with a negative, if you have to factor it, I would try and pull out a negative 1 with any other greatest common factor that you can. So in that case, it was just x squared. But then whatever's left in the parentheses, you want it to start with a positive term, so that way you can factor it faster. So then, all right, I have just out in front, I have negative x squared. To make that 0, I would just plug in 0. This has a multiplicity of 2, so we'll have a bounce there because that's even. Then we just have 4 and negative 4. There's just, would be, I mean, I guess it's a multiplicity of 1, but usually people don't say that. But that should just go straight through the x-axis at the 4 and the negative 4. Just go through the x-axis. At the 0, we're going to bounce. So I'm going to put a dot at negative 4, a dot at 0. And you don't have to do this, but like I just circle it so I tell myself, like, don't go through the x-axis when you get to that point. And then the 4 on the far right. Now, both ends of this, because it was negative and even, on the far left at the negative 4 and at the far right at the positive 4, it's supposed to go down. So you're going to go through the negative 4, and I'm going to try to draw a parabola the best I can. Kind of come down, you're going to touch 0. You're going to bounce back the direction that you came, and you're going to come back down eventually to go through the 4. So it kind of looks like the McDonald's arch, if you will. So something like that. It doesn't have to be perfect. I'm just going to look for your zeros and your end behavior. That's why the y-axis is not labeled. Is anybody having a question?